Hi everyone, welcome to Kinesiology 331. This class is called Personal and Community Health, but it's going to be taught this semester as a physical activity epidemiology class. So I'll explain what that means. We're going to give a brief introduction today of epidemiology and define some of the key terms that are going to be important for the rest of this semester. So what is epidemiology? Well, the definition is the study of the distribution and the determinants of health-related states or events in specific populations. So this can be thought of in several different ways. First of all, the distribution is really who has the disease. Men, women, certain racial groups, people of certain ages. How can we describe who has whatever disease we're interested in? For example, if we're interested in lung cancer, you may think, oh, people who smoke have lung cancer. And so it could be that the distribution of lung cancer is different amongst smokers compared to non-smokers. That's just one example. Maybe if you think about breast cancer, the distribution is much, much higher in women than it is in men, although it is possible for male to develop breast cancer. But that's another example of how the distribution can be described. The distribution can sometimes help us determine what causes a disease or a condition. For instance, if you go back to lung cancer and you see that the distribution is higher in smokers, that may lead you to wonder, well, does something about smoking cause or determine development of lung cancer? And then you can study what causes that health-related event. And then once we know what causes a disease, then the next step, of course, is to determine what we can do about it. Can we treat it? Can we prevent it? And so forth. So here's an example of a distribution map. This is an obesity map, and this is showing the distribution of obesity in the United States by state. So states that are colored in yellow, 20 to 24% of the population in that state is considered to be obese. We'll talk later in the term about obesity and how we define it. And then the orange states, the 25 to 29% of the population is obese, and then the states in red have the highest prevalence of obesity. More than 30% of the population in those states are classified as obese. So again, this is an example of a map showing distribution. Who has the disease? People in the southeast United States, according to this map, are more likely to be obese than they are in the rest of the country. Determinants can also be thought of as what causes the disease. Sometimes another term that's used is risk factor. So determinants can tell us what factors might put someone at risk for developing a disease. So a risk factor is a characteristic that, if it is present, increases the probability of disease. For example, smoking, we know, is a risk factor for lung cancer. If you smoke, that doesn't mean you definitely will develop lung cancer. And if you don't smoke, that doesn't mean you definitely won't develop lung cancer. But smoking is a known risk factor. It increases the chances of developing lung cancer. Epidemiology, this field really developed out of outbreaks. So John Snow lived between 1813 and 1858, and he is famous for studying the outbreak of cholera that occurred in 1854 in London. And up until this point, it was thought that cholera, the disease cholera, was caused by bad air, and that's really the extent of the understanding that people had about this very deadly disease. But John Snow started wondering if the cause could be contamination of the water supply. The reason that he thought this was that he noticed that there was a high density of cases of cholera near one particular well, a water source. And he also noticed that even though there was a prison very near this well, there was a low density of cholera amongst the prisoners. But he thought that could be explained because the prison has its own separate water source. And then he also noticed that there was no cholera in the workers who were employed at a brewery nearby. And he thought this might be explained because the workers drank beer rather than water, and perhaps something in the process of making the beer would get rid of the organism that would cause the cholera. So you can see how studying the distribution of cholera helped John Snow, who's now considered to be the father of epidemiology, help him to determine that the cause, or then a determinant, was something within the water supply. So here's a map of the cholera outbreak. The darker middle circle is the highest rates of cholera, very close to this well, where presumably all of the population gets their water from this one source. And then as you get further and further from that source, and the colors of the circles get lighter and lighter, that means that the prevalence or the occurrence of cholera is lower and lower. So the further you get from that well, the lower the risk of developing cholera. So again, this is an example of how studying the distribution can help identify the determinants. So this cholera study is classic epidemiology, which is why Snow is referred to as the father of epidemiology. He described the distribution of the disease and then used that descriptive information to identify a risk factor. In this case, it was water contamination. And then the next step, of course, is to prevent the disease by modifying the risk factor. So that in this case, that would be treating the water source to kill the microorganism that causes cholera. And so this class, this semester, is a physical activity epidemiology course. So what does that mean? What we're going to talk about is the study of physical activity levels across populations. So we're going to talk about different age groups. We're going to talk about men and women. We're going to talk about people of various disease states. We'll talk about children. We'll talk about elderly, pregnant women, individuals with disabilities, and so forth. And how we can describe physical activity levels in populations and how we can figure out how physical activity relates to disease. And then, of course, the step that's the most challenging is study how we get people to be physically active. So the next portion of this first lecture, I'm going to give you some key definitions. We're going to be talking about physical activity, exercise, and fitness a lot during this term, and I want you to be very clear on what these definitions are, because if you use them incorrectly, or if you hear me use them and don't understand the correct definition, that will impact our understanding of the concepts. So first of all, what is the difference between physical activity, which I'm going to abbreviate a lot this semester as PA? What's the difference between physical activity and exercise? Sometimes these are used interchangeably, and they are similar, but they have a pretty distinct difference. The definitions that I'm going to share with you come from a paper published by Casperson and colleagues in 1985. And this paper says that physical activity is any bodily movement produced by skeletal muscle that results in energy expenditure. So, movement of the body that is produced by your muscles that results in energy expenditure, meaning calories are burned. So this can be a whole host of activities. This can be occupational, meaning related to your job, standing, carrying, climbing, walking, whatever it is. It could be sports. It could be household, it could be dusting, vacuuming, cooking a meal, it could be taking out the trash, you name it. It could be activities designed for physical conditioning. Anything that is movement produced by skeletal muscle that causes you to burn calories is considered to be physical activity. Exercise is always physical activity, but physical activity is not always exercise. So exercise is defined as a subset of physical activity that's planned, structured, and repetitive, and has the objective to improve or maintain fitness. So going to the gym and working out is exercise. But walking to class, that's not exercise, that's physical activity, because walking to class is not planned, structured to improve or maintain fitness. It's designed to get you to class. So physical fitness is another important definition to talk about. Fitness has a lot of different meanings. You may have even heard of Darwinian fitness, survival of the fittest. That is a concept completely unrelated, and yet the word fitness is used in both cases. In this case, we're talking about fitness as cardiorespiratory endurance. This is really the ability of your cardiovascular system and your respiratory system, your heart and your lungs, to transport oxygen to your muscles, and then for the muscles to use that oxygen to fuel your body, to make ATP, which is essentially a fuel that your body uses to move. We can measure fitness by measuring your VO2 max, your oxygen consumption. So how much oxygen can your body use maximally? And so ideally, to measure fitness, we measure VO2 max. And so here's a couple questions to think about. Can you be physically active and unfit? Can you get physical activity regularly but not be fit? And research shows the answer is yes. There are individuals who get physical activity but are not fit. This is probably due mostly to genetic causes. Some people have a hard time improving their fitness regardless of what they do. Can you be physically inactive and yet fit? So can you be very good at using oxygen at the muscular level but not be physically active? And again, the answer is yes. Both of these scenarios are fairly rare, but it is possible. We've probably all met that person who never exercises, never works out, but they could go run a 10K tomorrow, no problem. That's probably the example here. Somebody who is just genetically gifted to be able to perform at a high level or a relatively high level despite being inactive. Again, these are the exception, not the rule, but there are some physical activity does not always equal physical fitness. And then a final definition I want to mention is sedentary time or sedentary behavior. This is prolonged sitting. It's usually at work, in automobiles, and with screen-based entertainment. So transportation, occupational, and screen time. So there's this relatively new argument that too much sedentary time is an independent risk factor for chronic disease. This means that not only is being inactive a risk factor for diabetes and heart disease and so on, but sitting also is a different, separate risk factor. So you could sit a lot and still meet the physical activity recommendations. So most people with sedentary occupations spend between 9 and 11 hours a day sitting. They may spend another 4 hours watching TV, reading, eating, commuting, etc. So here's an example. Someone wakes up at 7 a.m. and they go to the gym and exercise for 45 minutes. Then they drive to work, 45 minutes. Work on the computer for 4 hours, have lunch, work on the computer, drive home, eat dinner, watch TV or read until 11 p.m. when they go to bed. Well, this person has been sitting for more than 14 hours over the course of the day, yet they got 45 minutes of exercise, and we'll talk in a moment about the physical activity recommendations, but essentially the recommendation is about 30 minutes a day of physical activity. So this person meets the recommendations, and yet they sit almost all of the day. That's still a risk factor for chronic disease, even though they meet the physical activity guidelines. This is from your textbook. It's an example of someone, what they call a prolonger versus a breaker. So this data is from an accelerometer, and this is a device that measures physical activity. And what you see, basically the dark sections are time that's spent constantly sitting, and the white is broken up time that's not sitting. Okay, and these two individuals, the prolonger and the breaker, they have the exact same total amount of sitting time. But what you see is that the prolonger sits for long periods of time, whereas the breaker gets up more frequently. Again, they sit the same total amount of time, but it's just broken up differently. Prolongers, research has shown, have much higher risk of cardiovascular disease than the breakers. So it may be important that the frequency of taking breaks can impact health. So the United States government has actually come out with a recommendation on physical activity for Americans. This was published in 2008. It's called the U.S. Physical Activity Guidelines for Americans. And what it says is that the average American needs 150 minutes per week of moderate intensity physical activity or 75 minutes a week of vigorous intensity physical activity. Keep in mind that it's physical activity. It doesn't have to be exercise. Okay? The recommendations are true for every single group: elderly, pregnant women, people with disabilities, with the exception of children and adolescents who actually need more physical activity. They need 60 minutes per day. In general, the principles of these guidelines, more is better, so the 150 minutes per week is really a baseline. More is better than that. But also, some is better than none. So 100 minutes per week is better than 50 minutes per week, and 50 minutes per week is better than 0 minutes per week. Even if you don't meet that 150 minutes, some is better than none. And then lastly, start slowly, build up intensity and the amount gradually. This is to prevent burnout and injury. What about sedentary time? There's really no clear recommendation yet. There's not nearly as much research about sedentary time and health as there is about physical activity, but research is emerging showing that sedentary time is dangerous and it should be avoided as much as possible. So on the screen you see some examples of how people are trying to avoid too much sedentary time. You can see the school kids at their pedal desks getting some physical activity while they're working, and then the woman walking on a treadmill at her workstation. This is becoming a pretty popular way to increase physical activity at work. How do we measure physical activity? We're not going to talk about this extensively at this point. We'll bring it back up again later on in the term. But pedometers, this red device here on the left that you see, and then the purple one on the bottom, are both pedometers. They count the number of steps that you take. The accelerometers are the watch on the bottom left, and then the device on the far right. These are essentially more sophisticated pedometers. They don't count steps. They produce an algorithm. They give you something called counts, and basically the accelerometers measure accelerations of your body in 3 different planes, so they're much more sophisticated and accurate than pedometers are. We can also measure physical activity by diaries, where the person writes down, I walked this far, or I played basketball for 10 minutes, or whatever it is. They must keep track, and then there are surveys and questionnaires, many different versions used to measure physical activity as well. Fitness can be measured in either the laboratory or the field. In the laboratory, VO2 max testing is done. This is very intensive and requires a lot of equipment and expertise. You can see the picture of the man running on a treadmill. He has a heart rate monitor strapped to his chest, and you can see that he has a headpiece where he is breathing into this apparatus while he exercises. VO2 max test involves collecting oxygen and carbon dioxide that is breathed in and out during exercising to actually calculate the amount of oxygen that the body uses. And so this is, again, a pretty invasive test. We can actually do this in the kinesiology department in our lab, but most people don't have access to this type of testing, so field testing can be used. It's much more simplistic. These are all sub-maximal or less than maximal tests. With the VO2 max test, you have to exercise until you can't go any longer. But sub-maximal testing, you can exercise at a lower intensity, and it's based on the idea that your heart rate goes up linearly as your oxygen consumption or your VO2 goes up. So there are several different varieties. The most popular are the 12-minute walk, where you walk as far as you can in 12 minutes. The 1.5-mile run, where you run 1.5 miles as fast as possible. And then a 3-minute step test, where you step up and down on a step of a known height at a set cadence for 3 minutes, and then measure your heart rate at the end of that. And again, all of these are based on this idea that your heart rate goes up more the harder you're working, essentially. So if you had a lower heart rate, then if I had a heart rate of, say, 150 beats per minute after a test, and someone else had a heart rate of 170 beats per minute, we could assume that I'm more fit because my heart rate was lower. I was basically not doing as much work, or I wasn't working as hard. Okay, so that is all of the content for today. You need to post your introduction on the forum on Moodle by tomorrow at noon, and you also have your first quiz due tonight by 11:59 p.m.